Today we're going to talk about solving literal equations. What are literal equations? Well, looking at the sheet, there's a whole bunch of them. What are literal equations? What makes those equations different from a regular old equation?
Letters.
They had letters. A literal equation, that's just a fancy way of saying a formula. So a literal equation is a formula. And a very important skill in a lot of classes, a lot of areas, chemistry, physics, biology, is to be able to rearrange formulas. So what I mean is, this first one, A equals P plus PRT, we would say this equation is solved for A. What do I mean when I say solved for A? A is all by itself on one side, and there's no A's at all over on the other side. Quite often what we need to do is rearrange these formulas, and this one is saying take this formula, rearrange it, solve it for R. Which means when you get done, you should have R all by itself on one side and no R's at all on the other. How do you do that? Exactly the same way you would do it if you had numbers. All right, so for just a minute here, I'm going to plug in some numbers. So make up a number for A. 3. 3 equals, make up a number for P. 7. Plus, T we'll call 6. So if P is 7 and T is 6, what's 7 times 6? 42 R. So just for a minute, let's pretend that we didn't have letters. Let's just pretend that we had numbers. If I gave you that equation and that equation had all those numbers in it, how would you get the R all by itself? You would subtract 7 first, and then you would divide. So you would have minus 4 equals 42R, and then you're exactly right, you would divide. So your answer would be R is minus 4 over 42, which you might reduce to write as minus 2 over 21. Solving for R in this equation is really no different, except you don't have letters and you don't have things that you can combine and put together. Couldn't see my final answer there. Slide it over. Okay, so we're trying to get this R right here all by itself. So what would you do? Subtract the P. Just like over here you subtracted the 7, you do the adding and subtracting first. We do the adding and subtracting first. So we're going to subtract P. The big difference is when we did 3 minus 7 over here, we could call that minus 4. What do we have to call A minus P over here? A minus P. You can't combine those, can you? They're different letters. A minus P equals PRT. Now what? Divide by PT. Just like on this problem, we had 42 times R. We divided by 42. We're multiplying things by R. To get rid of multiply, you do division. So it looks like my final answer is R equals A minus P over PT. That formula would be solved for R. We have R all by itself on one side, and we don't have any R's at all over on the other side. Questions on that one? Number 2, that should look like a familiar formula. Y equals mx plus b. What's that formula? It's not slope. It's slope intercept. What's the slope formula?
Y2 minus Y1.
Y2 minus Y1 over X2 minus X1. This is the slope intercept form of a line. This is not the slope formula. But what I want you to do is I want you to take this formula and get the letter M all by itself, get the slope all by itself. What would you do?
Subtract B.
Subtract B. Same sort of deal. When we're solving, we take care of the adding and subtracting first. Since we have an add B, we get rid of that. We do a minus B. Y minus B equals mx. And then divide by x. Get rid of multiply, you do division. So our answer would be M is Y minus B over X. Questions on that? All right, number 3, I think nearly everybody had number 3 done quickly. What did you do to get the x all by itself?
Subtracted by.
Subtracted by on both sides. You get rid of the addition first. So ax equals c minus by. And then to get the x all by itself, divide by a. So x is c minus by over a. Now, number 4 is interesting. There are a bunch of different ways to do number 4, and I think walking around, I saw almost every different way that number 4 could be done, except the way I would have done it. So let me tell you what I saw. First, I saw some people say, I'm going to go ahead and I'm going to use a distributive property, and I'm going to multiply that through. Not a bad idea. Oh, what's this the formula for, by the way? Anybody recognize this formula? This is, if I give you a Fahrenheit temperature, this allows you to convert to Celsius. That's what this formula is for. Anyway, some people multiplied through by the 5/9. They got C equals 5/9 F minus, and then you take 5/9 times 32, and you should write that as 160 over 9. Don't give me a decimal there. Don't mix fractions and decimals. Use your calculator. Use that fraction button on your calculator. Okay, so that kind of helps. That gets rid of those parentheses. And then what do you do to get the C all by itself from there? Add the 160 over 9 to both sides. So C plus 160 over 9 equals 5/9 F. And then finally, to get the F all by itself, divide by 5/9. So F is C plus 160 over 9, and the whole thing is divided by 5/9. And that's a correct answer. I saw people do it that way. The other way I saw people do it, I saw some people say, I'm going to get rid of this 5/9 right from the beginning. So some people went ahead and immediately divided both sides by 5/9. And they wrote C over 5/9 equals F minus 32. And then how do you get the F all by itself? Add 32. So C over 5/9 plus 32 equals F. Are those the same answers? They don't look it, but they really are. They're the same answers written in two different forms. Here's what I would have done. I would have said, I see I have an equation, and this equation has fractions. I don't like fractions. So what I would have done is I would have started by multiplying everything by the common denominator. What's the common denominator? 9. What happens when I multiply the left-hand side by 9? 9C. What happens when I multiply the right-hand side by 9? No. What does multiplying by that 9 do to that 9 on bottom? It cancels that 9 on bottom. So when I multiply by 9 here on the left-hand side, I take the 9 times the 5/9. The 9s go away. And what am I left with? A 5 times F minus 32. That would have been my first step. My first step would have been make the fractions go away. Multiply by 9. Then I have 9C. I distribute is 5F minus 180. 160, sorry. Yep, 160. Add the 160. 9C plus 160 equals 5F. And finally, I divide by 5. F is 9C plus 160 divided by 5. Which way is the right way? Guess? No, guess is awful. Oh, yes. Yes. All three of them are the right way. Which way is the right way? Whichever way made the most sense to you, that's how you should do it. Okay? As I was walking around, many people had that one correct. That was very good. Okay, sometimes when we have literal equations sometimes to solve involve factoring. Here we have a equals 2 pi r squared plus 2 pi rh, and it wants us to solve for pi. Anybody know what that formula is for? It's almost pi r squared, that part's area of a circle, but then we multiplied it by 2. Then we got this other thing over here, 2 pi rh. I'd be surprised if anybody knew this one. This is the formula for area of a cylinder. So a cylinder, you have a circle on top and a circle on bottom. So that's pi r squared, that's the area of the top, the area of the bottom, you got to do it twice. And then this is the area of the side of a cylinder. So think of like a soda can. This is the formula for area of a soda can. Anyway, the thing to notice is we want to solve for pi. And when you look over here, you should notice that you see pi in 2 places. If you wish to solve for a letter, in this case the letter pi, and you have 2 of the pi's in your formula, that tells you you're going to need to factor. What do I mean by factor? Take out your common factor. In this case, the common factor is really more than just the letter pi, but since we want to solve for the letter pi, we're just going to take that out. So I'm going to write a equals, I'm going to factor out the letter pi. What do I have left over when I factor out the common term of pi? 2r squared plus 2rh. How did that help? There's only one pi written now. That's a good thing. And I can just divide by this whole mess, and then the pi is going to be all by itself, isn't it? So I divide by this whole mess, 2r squared plus 2rh. Do it on both sides. 2r squared plus 2rh. My answer is pi equals a over 2r squared plus 2rh. Questions on that one? All right, number 2. I'm going to do number 2, and I'm going to do it wrong on purpose. And then we'll do it right. I'll show you what's wrong, and I'll explain why people do this. Okay, so what I would do on number 2, this is going to be my wrong answer. Wrong, just to be clear. I'm going to just distribute first to get rid of that 2. 2LW plus 2LH plus 2HW. Nothing wrong there. That's fine. I distributed the 2 through. Now what I'm going to do is I'm going to subtract on both sides. I'm going to subtract 2LW and I'm going to subtract 2LH. And I'm going to do that on both sides. So I'm going to have S minus 2LW minus 2LH equals 2HW. And finally, to get the H all by itself, I'm going to divide. What do I divide by? 2W. So I would write H equals S minus 2LW minus 2LH over 2W. Did I solve for H? Do I have H all by itself on one side?
No.
Well, I do have H all by itself on one side, but what's wrong? I still have an H on the other side. So when we say solve for H, we do mean get H all by itself on one side, but we also mean you are not allowed to have H's on the other side. And this is a very, very common mistake that students will make. They'll get H on one side, but they still have H's on the other. All right, so that's the wrong answer. What should I have done to do this correctly? I got to do like I did with the pi. I got to take the pi out, except in this case it's an H. Multiplying by 2 is not a bad idea, so I'm going to do that again. So I'm going to write this as S equals 2LW plus 2LH plus 2HW. Now, what I need to recognize is that I have H in 2 places. There they are. What I want to do, what I need to do, is I need to take this equation and I need to have everything that has an H on one side and everything that does not have an H needs to be on the other side. So if I want to keep the H's together on this side, what do I have to do? Subtract 2LW. I want all the H's on one side, all the not H's have to be on the other side. Please put your cell phone away. I subtract 2LW on both sides. So I have S minus 2LW equals 2LH plus 2HW. Here's the reason why we wanted to do that. We wanted all the H's on one side, all the stuff without H on the other side, so that we can factor. What do I mean by we can factor? What can I factor out on the right-hand side? I can factor out 2H, that's true, but really all I want to factor out is H, because that's the letter I'm trying to solve for. I could factor out the 2, it's not wrong, but since H is the letter I want, I'm only going to factor the H. S minus 2LW equals H times 2L plus 2W. Okay, so there's the whole key. We get all the H's on one side, all the not H's on the other. That allows us to factor out the H. And after we factor out the H to get it all by itself, divide. Final answer is H equals S minus 2LW divided by 2L plus 2W. Now we have what we want. We have H on one side all by itself. We do not have any H's over on the other side. There's the right answer. Questions on that one? Oh, here's a fun one. One with fractions. 1 over F equals 1 over A plus 1 over B. We want to get B all by itself. What would you do? Subtract 1 over A, and then? Not a bad first step. But then the B is still on bottom. How are you going to get that B up to the top? I'll give you a hint. You can't just flip.
Multiply both sides by B.
Multiply what?
Both sides by B.
Absolutely, but I wouldn't multiply just by B. That'd be over 1. What would you do if you had, let's say, 1/2 equals 1/3 plus 1 over B? What would you multiply by? Not 3. You find the common denominator. What's the common denominator there? Well, what's the common denominator for a 2 and a 3? 6. And then what do you do with that B? Your common denominator is 6B. What I'm going to do is I'm going to take this thing and I'm going to multiply everything by the common denominator. What happens when I take 6B and I multiply it by 1/2? Well, what's 6 divided by 2? 3. So that gives me a 3B. Equals, over here, what's 6 divided by 3? So that's a 2B. Over here, oops, not equals. What's 6B divided by B? 6B. Nope, just 6. This b on top cancels with that b on bottom. I saw an equation. My equation had a whole bunch of fractions in it. The first thing I always do is multiply by the common denominator. Why? It makes all the fractions go away. How would you solve that now? Minus 2b, and this one's real easy. You get b equals 6. For this problem over here, I would do the exact same thing. I would find the common denominator. What's the common denominator? FAB is all three of them, just like it was on this one. We had the 2, the 3, and the b. That gave us a 6b. Same deal here. The common denominator is all three of them. So I'm going to take everything, and I'm going to multiply it by FAB. What happens when I take the FAB and divide it by F? AB. The F's cancel out. AB equals. What happens when I take FAB and divide by A? I have FB plus FAB divided by B. FA. So notice what we did. We took a problem that had a whole bunch of fractions. We multiplied by the common denominator. All the fractions go away. Makes your life a whole lot easier. What's next? Get all the b's on one side, all the things without b on the other. So how would you do that? Subtract FB. That'll put all the pieces with b's on the left, all the pieces without b's on the right. So I got to subtract FB. AB minus FB equals FA. Almost done. Next step is factor. That's why we got all the b's on one side. We got all the b's on one side so we could factor. Take out the b. Left over a minus f. Oops. A minus f. That's really an f. Equals fa. Finally, we divide. B is fa divided by a minus f. Questions on that one? All right, I'm running out of time, so I'm going to jump down to number 5. Number 5 is another one with fractions. The fraction ones usually are the ones that scare people the most. What would you do on number 5? Times by bx. Times what by bx?
Both sides.
Both sides, which means everything. And a very common mistake is people just see the number 2 over here, there's no fraction. But if you're going to multiply by bx, you've got to multiply everything by bx. So we're going to multiply by bx here, by bx there, and by bx there. Remember, multiply everything. Even though one of them is not a fraction, you still have to multiply. What happens when we take bx and we divide it by b? We just get x. Plus, what happens when we take bx and we divide it by x? The x's cancel out, and then we've got 2b times b. 2b squared. Equals 2bx. Okay, so again, there's the common theme. When you have fractions, don't let the fractions freak you out. Multiply by the common denominator, get rid of the fractions. Now what? Subtract 2bx. Subtracting 2bx is not wrong. But I think what I would do rather, I'm trying to get x all by itself. I think I would just subtract the x. Because then if I subtract the x, I'm going to have everything with x's over on this side, and this 2b squared doesn't have the x would be on that side. That would be, I think that's the easiest way. I could subtract the 2b squared, and again, you're tempted to say you're all done, but you're not. Why not? You would have this x on the left, but you still have another x over there on the right. So again, don't fall into that trap. If you subtract the 2b squared, you don't really have the right answer. You've got the x all by itself on one side. Unfortunately, there's still x over there. So I think a better idea here is subtract the x, get all the x's on one side. 2b squared equals 2 bx minus x. Why do we want all the x's together on one side? So we can factor 2b squared equals x times 2b minus 1. Don't forget the minus 1 there, that's easy to do. Finally, we divide. Our final answer is going to be 2b squared over 2b minus 1 equals x. Questions on that?